Hey everyone, this is your AP Physics 1 exam number 3 tutorial. First, I'm going to go over problem 1, 2, and 3 because they are based on two diagrams. So let's first construct the diagram. Write diagram 1 here. So this is diagram 1, this is VT, and this is diagram 2. This is also VT. Diagram 1, velocity, you're going to keep it constant. So the velocity is from 1 meter per second to negative 1 meter per second. So the object is moving 1 second with 1 meter per second. And then object turn around, right? Change the direction and moves with negative 1 meter per second for additional 1 second. So this is 2. If you want to visualize dt graph, or even if you visualize one dimensional, we did in the class, the object is moving from location A to B with 1 meter per second, and immediately when it comes to location B, immediately change the direction and come back to A. VT graph should be straightforward. This is 1 between t is between 0 to 1, and this is negative 1. T is between what? 1 to 2, and the dt graph should be t 0 to 1, 0 to 1, and t minus 2 from 1 to 2. And how would that look like? This is dt. That look like a diagonal line, a positive diagonal line. Slope of this one is a positive straight line. This is a negative diagonal line. The slope of this one is a negative straight line. That's what I mean. This equation is this equation is this. Great. So the total displacement is 0. Now the second one is a little bit interesting because the velocity, this is 1, let's say this is 2. At 2 second object completed, at 2 second object the speed is 1 meter per second, and it increases because it's quadratic. So velocity quadratic is interesting. One example of velocity is quadratic is rocket science, rocket launching. Fast 2 to 3 minutes. Okay, so fast 200 seconds. The rocket, when rocket launches, the velocity has to be quadratic. So there is some kind of jerk. Speaking of jerk, you want to take a look at your dt graph. So understand few things. If velocity is constant, then x is ct. If velocity is linear, then x is k over 2 t squared. If velocity is a quadratic, k over 3 t cubed. Okay, in this here this one is the case. This one is the case because the velocity is quadratic. So the velocity is quadratic. How do we know velocity is quadratic? Let's find whether velocity is quadratic. Look like velocity is quadratic. I have 2 point 0, 0, which is hk. I have 2, 1. So y is equal to x minus h squared plus k. So y is equal to, don't forget a. So y is 1. 1 is equal to x is 2 minus 0 squared plus 0. So a is 1 over 4. If a is 1 over 4, then how can we write the equation? Y is 1 over 4 t squared. Okay, so we know the equation for this one. V of t is equal to 1 over 4 t squared. This one is 1 over 4 t squared. Then x, the dt would be what? We see that x is k over 3 t cubed. Okay, so then what is our k? Our k is 1 over 4. So then x is 1 over 4, right? K is 1 over 4. So 1 over 12. 1 over 12 t cubed. Let's see our v. We already we found the v. So at would be, so we're gonna draw v now. We already have b. We're going to draw dt. dt. So dt is at 0, 0, let's say 10, is going to be 80. This is your dt. They look same, but this one increases faster because this is cubic. dt is 1 over 12 t cube. This one increases faster. So then 80, if vt is quadratic, 80 would be linear. So this is 80. So we're going to use the same procedure. So this is 1/2 t. Then we're going to do Zark, and that is just half. So this is meter per second. This is meter. This is meter per second square. This is meter per second cube. Okay, and this is half. Okay, now this is all our graph. Understand, this is using graph. At 2 seconds, this one travel only 0 meter. Why is that? Because it's back to origin. At 2 seconds, this one travel how much? Let's see. 1 over 12, 2 cube, which is 8. So 1 over 12, 2 cube. So 1 over 12, 8. So 4 goes to 2, 4 goes to 3. So 2 over 3, 2 over 3 meters. Okay, that's not what I asked you. I did not ask you to give me that much precise information. At 2 seconds, this one travels 0 meter. At 2 seconds, this one travels 2 over 3 meter. That's not what I asked you. I asked you which one travel more distance at the more displacement at the end of 2 seconds. At the end of 2 seconds, this displacement is 0 and this displacement is 2 over 3. So this one travel more displacement at the end of 2 seconds. So the answer is, of course, this diagram B. The question number 2 is, which object moves with non-zero constant acceleration? This is constant acceleration, but this is not non-zero. In fact, this is zero acceleration. So not this one. This one, acceleration is not constant. Acceleration is linear. Okay, so none of them. Question number 3 is, which one is back to origin at the end of 2 seconds? That's like question number 1. Okay, so question number 1, the object is back to origin at the end of 2 seconds. Now, what is the real life application of this one? Let me see. When we start force, we're going to be explaining this more. Newton's second law tells us F equal ma. So acceleration is F over m. So if you are a rocket, right? If you're a rocket, then you have to move at the y direction, right? All the velocity has to be at the y direction. So 90 degree. So all the velocity has to be, Vx has to be 0 and Vy has to be 100%. Another way of saying that, Vx is V cosine theta and Vy is V sine theta. And in this case, theta is 90 degrees, so x is going to be 0 and y going to be 100%. Now, acceleration was going on with the rocket. F thrust minus Fg minus F drag over m. As rocket go from 0 kilometer, let's say, to 1,000 kilometer and above 1,000 kilometer, from here to here there is a air drag. After here there is no air drag. So after there, acceleration is F thrust minus Fg over m. However, the m goes down. Why? The fuel that the rocket has when the t is equal to 0 is enormous. It's like most of the weight comes from the fuel. As the rocket burning the fuel, m goes down. If m goes down, what happens? This goes up. If this goes up, acceleration go up. So acceleration increases. For how long? About 1000 kilometers. After that, the acceleration remain constant. Okay, so that's an example of rocket launching. We'll see more example in the class. But that's your question 1, 2, and 3. You did not have to know all those things to answer this question, but I wanted to give you some math understanding behind this because the math is the language of physics. So let's go over problem number 4 from AP Physics 1 exam 3. Problem 4 is interesting many ways. I gave you velocity versus time graph between 1 meter per second to negative 1 meter per second. Constant acceleration from 0 second to 0.5 second. Right? And it moves with constant acceleration from 0.5 second to 1 second. Its continuum moves with constant acceleration. Let's move to 2 meter per second. So let's say 2, 2. It continuum moves with constant acceleration from 1 second to 2 seconds. From 2 seconds to 3 seconds, it moves with constant velocity. From 3 seconds to 4 seconds, again it moves with constant acceleration. Notice that at t is equal to 0, object is at origin. At t is equal to 1, object is back to origin. I did not make it so difficult. I said option 1, 1 second, option 2, 2 seconds, option 3, 3 seconds, option 4, 4 seconds, option 5, 1 to 2 seconds, option 6, 2 to 3 seconds, option 7, 3 to 4 seconds. This is not exactly the order I gave you, but these are the options you have. To understand what really I ask you, you have to understand the kinematics. The area over here is, let's see, the area over here. First find the area at 1 and then area at 2. Area at 1 is, area is half BH. So area is half, B is 0.5, H is negative 1. So area is negative 1 over 4. So area 2 is, so the total area would be twice as this one. So area would be negative half. So area here is negative half. Okay. So how that going to help you to find? The answer is the object return to origin between 1 to 2 seconds. How that going to help you find out? Okay, now from 1 to 2 seconds, area is also half BH. Half B is 2 minus 1 is 1. H is 2. This area is 1. Understand that this is negative half. This one is negative half. I'm going to write it inside, so you'll be able to visualize, because this is as technical as it can get. So this is negative half. This is a positive 1. So positive half lies between 1 to 2. If the whole thing is 1, then positive half lies between 1 to 2. Somewhere here, not 1.5 exactly, not 1.5. I don't want to mislead you. Not 1.5. This is 1.5. Lies between 1 to 2, between 1 second to 2 seconds. It doesn't have to lie between it doesn't have to lie at 1.5 or 1.6. We don't know. We're gonna just say t. All right. At t, there must be area which is positive half. So negative half and positive half cancel. The object is back to origin. So we're just gonna say t. We're gonna find that t, and that t is lies between 1 to this t is lies between 1 to 2 seconds. It could be 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, 1.9. It could be anything. So let's find it out. Let's exactly draw DT graph so you understand better. Negative 1.4, this is negative half. At 0.5 second, you are negative 1.4 away from the origin. At 1 second, you are negative half away from the origin. At some second t, right? At some second t, you are I don't know exactly what. At some second t, you are back to the origin, and this is your origin. So we're gonna draw it like this. At some second t, you are back to the origin, and you never back to the origin again. And that's how it should look like. So now we're gonna find out what second is this one. Now you have some idea what's going on. Okay, because at this one you are back to origin. Okay, so this is half BH, area is half BH. So the area is, what is the area already? We have area is negative half is equal to half. What is B? B is time, and H is velocity. What is velocity? Velocity is VF. VF is equal to VI plus AT. VI is 0 over here, so we're just going to write 0. Acceleration. What is the slope of this line? This is 1 comma 0, and this is 2 comma 2. So 2 minus 0, 2 minus 1, so acceleration is 2t. But velocity, be careful, velocity is not 0. We have to report that. Velocity is 0 at t is equal to what time? At 1 second, velocity is 0, so minus 1. Okay, so we're going to come back. This is, I'm not going to just write that yet. The area is this. Area is, this is area A2. This is A2. Area A2. We want to find this t. So we're not going to replace t by 2 because this t is not 2. This t is less than 2. So A2 is half t minus 1. Why t minus 1? Because you started from 1 second. And this is the slope. What is the slope? 2. T minus 1. So area 2 is equal to this 2 cancel. T minus 1, T minus 1. So area 2 is equal to T minus 1 square. So T minus 1 square so area 1 has to be equal to area 2. Area 1 is negative half, and area 2 is T minus 1 square. Okay, so what is the total area? Area is, you're going to send this one to the other side. So half So what is the area? Area 1 plus area 2 has to be equal to 0, right? So that object back to origin. So area 1 is negative half. Area 2 is t minus 1 squared is equal to 0. So t minus 1 squared is equal to half. You're going to square root both sides. So t minus 1 is equal to square root of half is 0.7. So t is equal to 1.7. So finally we know this is 1.7. At 1.7, this is 0. At 1.7, so this is 1.7. So this is 1.7. But I didn't make it that complicated. But this is the real kinematics out of this problem. Horizontal projectile motion. The time depends on Vy. And the range depends on Vx. What do I mean? Let's consider a scenario over here. From location A to B, that's distance d, and you are driving. Location C to D, this is called range, right? So if Bx go up, range go up. If T goes up, range also go up. Okay, so why is that? Because dx is Vxt. Dx is range. If you look at the kinematics equation, d is equal to Vit plus half at square, you can write it in two different ways. So if this is d, this is dx, and this is dy. Right? This one right here at location B, when you off the ground and you want to land on D, right? You have a velocity over here. Vx is more than 0 and Vy is exactly 0. Why Bx is 0? Because Ax is 0. Bx is constant. Bx is constant. Okay, so if Bx is from here to here is, I don't know, if whatever Vx is from here to here is going to remain constant because Ax is 0. So Bx is constant. Vy on the other hand, the speed going to increase. Why is speed increase? Because Ay is negative 10 meter per second squared. It is just from 0 and it's going to be negative 1 meter per second, negative 2 meter per second, negative 3 meter per is going to, the speed going to increase. Okay. So we know the dx is Vxt. So if Bx increases, dx increases. If T increases, dx increases. The T depend on Vy, right? Okay, if Vy is 0, then T is small. Okay. Now, in this case, it is going to be projectile because let's say this is 20. So even the angle is 0, the projectile will stay in the air for a few seconds anyway. So I'm going to give you two scenarios and you're going to tell us what happened. Scenario 1. So an object starts moving from A to B, and at B, velocity Vx is less than 10. And Vy is 0 because it's off of the ground. When you're off of the ground and you're moving from A to B at the x direction, you have only velocity at the x direction over here, not y direction. But as soon as you are off of the ground, acceleration is g, so you're gonna accelerate to location C, and since there is a Vx which is more than 0, then you're not gonna land at C, you're gonna land at D. Okay, so that's the idea. So now if this is 20 meter, then the time it will take is 2 seconds. Why is that? Because d is half a t squared. Vi is 0, so you're gonna just write half a t squared. So dy is negative 20 is equal to minus 5t squared. So t squared is equal to 4, so t is 2. So the time is going to take 2 seconds. So the dx is vxt. So dx is 10 times 2. So this is 20 meters. From here to here is 20 meters. Now, if I double it, if this vx, everything else is same. However, if the vx is instead of 10, it's 20, but you keep everything the same. This is A, this is B, this is C, this is D. Now instead of falling over here, it's going to fall over here, it's going to land over here because the dx is going to be double now. Why is that? Because this is double. Let's see. Dx is equal to vxt. Dx is equal to vx is how much? 20. And t is, since this is 20 meters, is still 2 seconds. So dx is 40 meters. Now this range is 40 meters and this range is 20 meters. If you double the velocity at the x direction, then of course the range is double. Okay, that hopefully you understood the problem. If you don't, then of course let me know. Let me go over problem 8 and 9. I give you P, I give you Q, and I give you R. R is kind of here. Okay, and as you know that the Q is less than P, which is R. Okay, or you can say Q is less than R, which is P. So P and R, the speed at P and R are the same. This is dyt. Let me prove that. So this is dyt. The 3 dot, this is, let's say, P, this is Q, and this is R. You throw a ball, you kick a ball, let's say, we did it many times, 20 meters per second, and that is B initial at 37 degrees. So you have two components of velocity, Vx and Vy. Vx is V cosine 37, Vy is V sine 37. So this is 20 cosine 37, this is 20 sine 37, this is 16, this is 12. The time depend on this one. The range depend on this one. Okay, this one, Ax is 0, acceleration due to gravity. This one, Ay is g, acceleration due to gravity. Okay, now let's draw it nicely. Okay, so let's quickly find how long does it take at location 1, at location 2, location 3, location 4, and location 5. So location 5, vit plus half at squared. Now, since this one is 0, right, at location 5 this is 0 because displacement is 0. Vi 12, the time only depend on the y component, minus 5t squared. Okay, so 5t squared is equal to 12, factor of t. So you have 12 minus 5t. So t is equal to 0, okay, good. And 5t is equal to 12. So t is equal to 12 over 5, which is 2.4, right? So this is 2.4. This is 1.2. This is 0.6. This is 1.8. Okay. Velocity over here is Vx is 16. Vx is 16. Vx is constant, right? So that acceleration of that direction is 0. Vy is 12. Vy is this is Vy. Vf is equal to Va plus At in the y direction. So this is 12 minus 10t. So this is 12 minus 10t. 12 minus 10t. This is also 12 minus 10t. Okay, so 12 minus 10.6. So this is 6. Velocity at the y direction is 6. Velocity at the y direction is -6. Okay, so what is the Vxy at location 2? Vxy is speed, which is square root of Vx square plus Vy square. All right, so 16 square plus 6 square. 16 square plus 6 square, I think 17. 16 square plus 6 square, 17. Over here is also 17. Vxy at location 4 is equal to speed Vx square plus Vy square. So this is 16 square plus minus 6 square. So this is also 17. So speed is same. The speed is same, and speed over here is 0. Vy over here is 0. Vx over here is 16. All right. So the speed over here, you can say 16. So speed over here and the speed over here are same. Okay, so now let's write it down. This is P. The speed is 17. This is Q. Speed is 16. This is R. Speed is 17. So P and R are the same. Okay. And Q is less than P and R. Okay. The question number 9 is very easy. Acceleration due to gravity is always at the y direction. Here, y direction. Here, y direction. Here, y direction. Which is acceleration due to gravity. So acceleration due to gravity always at the y direction. That's the problem number 8 and 9. Problem 10 we have done many times in the class. So what is problem 10? With some familiar point, right? I gave you a dt graph with some familiar point. For example, this is 0, 0, so that's good. This is 1, 2, so that's good. This is 2, 8, so that's good. This is 3, 18. So that's very familiar. If you use y is equal to ax minus h plus k, what do you get? P of t is equal to 2t squared, right? Okay, now two way you can do it. I ask you to find the average velocity between 1 and 2. So average velocity, you can do average velocity two different ways. One is, well, let's first convert it to VT graph. This is VT graph. So if this is positive curve, this is diagonal. At 3, you have 18 meters. So A is equal to half BH. So 18 is equal to half, B is equal to 3, and then H. So velocity is 12. At 3, and the velocity is 12. So now what would be the velocity equation? So velocity is 12. Okay. All right, so VF is equal to VI plus AT. This is 0 plus acceleration 12 minus 0 divided by 3, so 4t. Okay, so this line is, what is this one? This one is V of t is equal to 4t. This one, P of t is equal to 2t squared, using this point and this point, well, this point, 3 comma 18. So we can use two ways. One is using this graph. So you can say displacement at 3, oh no, displacement at 2 minus displacement at 1 divided by delta t. Okay, displacement at 2 is how much? 8 minus displacement at 1, 2 divided by 2 minus 1, which is 1. So this is 6 meter per second. Okay, this is one way. The other way is velocity at 2 seconds is 4 times 2, 8. Velocity at 1 second, 4 times 1 is 4. So you have card, this is 0 comma 0, this is Vt. So at 1 velocity is 4, at 2 velocity is 8. So average velocity is Vf plus Vi over 2. So Vf is 8, Vi is 4, divided by 2, which is 6 meter per second. So this two way you can do it. So the problem is very simple. Problem 11 and 12, we did it many times in the class. This is Vt. Let's make it longer. This is Vt. Let's draw it. This is car, let's say this is car Y, this is car Y, and this is car X. This is car X. Okay, so this is V. Car X moves with constant velocity, car Y moves with acceleration. So let's say this is 20, let's say this is 40. Okay. All right, let's quickly find the equation, because if you see the equation, then it's going to be easy. Let's quickly say V naught is 10. That's a nice number. Okay, so first find the equation for car X. Very easy. So we can draw the dt graph as well. Okay, so this is dt. This is horizontal line, so this is going to be a diagonal line. This is a diagonal line, so this is going to be a quadratic. Okay, so I'm going to stop here, right here. This is an important point for us. This is also important point for us. This is, let's say this is 20. Okay, so at 20, the orange, the car Y moves how much? Half BH, right? So half B is 20 and H is 10. 5, so 100. At 20, the car X, BH, B is 20, H is 10, 200. So 200. So answer to question number 1, of course, the car X is way ahead of car Y at 20 seconds. Now let's check the 40 seconds. 40 second, let's put the d over here. This is 40 second. Both of them would be 400. Now then, which one is ahead? Of course, car Y is ahead than car X, because car Y moves twice as fast than car X. Let's prove that. So what is the equation for this line? The equation for this line is 10t. So this one is 10t. What is the equation for this line? Equation for this line is let's see equation for this line. Finding equation for this line is going to be easy. Vf is equal to Vi plus At. Vi is 0. A is let's see what is the velocity over there. So this area is 400, right? From here to here is 400. So 400 is equal to half. B is 40. S is the velocity, so 20. 0, 0 cancel. So 20. So this is 20. So 20 minus 0, which is 20. 20 divided by 40, which is 2 half. So this is half t. Vt is, this is half t. Okay. So then what is this one? Well, if we know this is half t, that's it. That's in itself going to help us. So at 40 seconds, this one going to move with what? At 40 seconds, this one going to move with, at 40 seconds, this one going to move with how much? 10 meters per second. And that would be this one. This one going to move at here, 10 meters per second. The other one going to move at how much? At 40 seconds. Other one going to move at half 40. 20 meters per second, as I said that. So of course, the car Y will be ahead of car X for this reason, because the car Y is accelerating. That is accelerating, right? From rest. Accelerating from rest. What does that mean? Velocity increases. Okay, how can you draw? dt has to be quadratic. Vt has to be linear. And At has to be constant. So problem 13 is super easy. 14 is interesting. I give you the east, west, north, and south. This is the scenario 1, and this is the scenario 2. West, east, north, south. Vector A in the diagram 1 at time 0, initial time, the vector A look like this. At time later time is equal to 1 second, the vector look like this. Now which way acceleration is acting? Okay, and now let's see. Let's break the vectors in component. This vector we're going to call v1, and this vector we're going to call v2. v1 has two components, vx and vy. Okay, all right, so let's put it down. Vx is this, and vy is this. Okay, and together you have this. Now let's v2. doesn't have x component. So vy, so this is v1 x, this is v1 y, this is v2x, which is 0, v2y, whole thing is this one. Now why you want to think why v2x is 0 is because the acceleration has to have two vector. If acceleration has two vector, if acceleration x in this direction, then acceleration will have two vector. The acceleration x ax and acceleration ay. Ax cancel the v1x. So ax cancel, this is ax cancel the v1x. So v1, by the time v1 comes to 1 second, v1x is 0, because acceleration at the x direction cancel the v1 velocity at the x direction. Some of the acceleration from the acceleration vector is acting at the y direction, and that's boosted up, that boosts this one up. So this one is end up getting a little bigger. This one is like, let's say 2 centimeter. Now this one is 3 centimeter. So then acceleration acting. Now if you think the acceleration is act only at the any other direction, that analysis won't work. Okay, all right. So now let's go to the 15. 15, I did projectile many times, so I'm gonna make it quick. This is a projectile. This is dyt. Let's say at vertex, time is equal to half. Vx is not 0. Vy is 0. Acceleration is -10 meter per second squared. So I give you a VT graph like this, and then I ask you to convert it to DT graph. Okay, so from location A to B to C to D. So A to B is a positive diagonal line. So if it is a positive diagonal line, then it has to be curved, a positive curve. So let's do it this way. Since this is constant, this one has to be diagonal. So this one, now this one is negative diagonal line. So this one is, of course, slowing down, right? This is negative diagonal line. This one's slowing down, slowing down, slowing down, and then there would be like 0 velocity. If you can draw, so let's draw it again. So this is like this, and this is like this, and this is like this. Okay, so if you draw a tangent line over here, the slope of the tangent line has to be 0. Okay, the slope of the tangent line has to be the slope of this line slope is 0. What does that mean? Velocity is 0. Okay, so at right here the velocity is 0. Okay, all right, so that's 10-meter tall building. This is location A, this is location B, this is location C, this is location D. C to D is 3 meter, and the target is right here. So what would be the velocity at location B? By is 0, of course, so that this projectile will hit the target, which is 3 meter away from location C. Okay, first we're gonna find T. So T is equal to VIT plus half AT square. So this is 0 because of the y direction. So this is 10 is equal to negative 10 is equal to negative 5 t square. So t square is equal to square root of 2. T is equal to square root of 2. So dx is equal to vix plus half ax t square. This is 0. This is 3 vix. We are trying to find vix t. So vix is 3 over t square root of 2. That's the answer. This is 2.12, I believe, meter per second. So let's go over this problem. Let's consider a dt graph. Past 2 second object moves 2 meter. Next 2 second object moves 0 meter. Next 2 second object moves additional 2 meter. So that means object is speeding up. Next 1 second object slow down to 0. I'm not drawing to this guy. Next 2 second object is speeding up and cover the distance of negative 3 meter. Next 2 second object slow down, covering 1 meter. Next 2 second object at rest. Next 2 second object. Okay, all right, that's it. If I ask you to find distance 9 seconds, how can you find it? That seems like a big problem. Well, not so much. Convert it to VT graph and everything gonna be easy. Okay, so I'm gonna use the word. Let's divide and conquer. Okay, so if this is diagonal, this is horizontal. If this is horizontal, this is 0. We don't need them. We need only at 9 seconds. So 9 is between 8 and 10. We need only that one. But I'm just doing it, I don't know, for fun. I don't know. Here, object moves 2 meters, 0 meter, 2 meter, 1 meter. So this is 2. So then velocity is the velocity is 2. Okay, here is 1. So the velocity is you have 1 is equal to half 2. So velocity is 1. So 1. Here velocity is this negative 3. This is 1, negative 1. This is 0. This is negative 1. Okay, so velocity is a negative 3. So this is negative 3. Okay, this velocity is negative 1. Velocity is 0. And the velocity is negative. Velocity is negative half. Okay. All right. So 9 seconds. Let's find out 9 seconds. Okay. So this area is 2. This area is 2. This area is 1, and we want to find this area at 9 seconds. This one. Right. This one. To know that, I have to know the velocity over here. I know the velocity over here. Velocity over here is negative 3. My prediction is velocity over here, let's probably negative 1.5. But how do I know? Okay, let's see how I know it. Let's find the velocity equation, because the velocity equation is same thing from here to here. So Vf is equal to Vi plus At. Acceleration is from here to here is the same. Why is that? Okay, let's write it down. Vi at 8 second Vi is 0. Acceleration is negative 3 over 2. Why? Because from here to here 10 minus 8 is 2.
So negative 3 divided by 2 is the acceleration. So negative 3 divided by 2, t minus, at what time the velocity is 0? Well, 8. At 8-second velocity is 0. So you have v of t is equal to 0 minus 3 over 2t plus 12. Now I'm going to plug in 9. If I plug in 9, then what I get? Negative 3 over 2, 9 plus 12. So what is the velocity? Velocity is negative 1.5, 13, negative 13.5 plus 0, so negative 1.5. Okay, so that's going to allow us to find the distance. How? We want to find the distance over here. So this is 9. So we're going to use half BH. Half B is 9 minus 8. H is negative 1.5. Negative 1.5 divided by 2. So negative 0.75. Distance can never be, so that's displacement. So you're going to take the absolute value. So you're going to get 0.75. So you're going to write over here 0.75. So 2 plus 0 plus 2 plus 1 plus 0.75. 4, 5, 5.75 meter, 5.75 meter, and this is 21. Let's find 22. At 22, the velocity at 9 seconds. We already found velocity at 9 seconds, right? At 9 seconds, velocity at is negative 1.5, negative 1.5 meter per second. And then I ask you to find the acceleration at 5 seconds. Acceleration, I'm going to move this one. Now let's do the acceleration versus time graph. We're going to only do at location 5, location 1, location 2, location 3, location 4. Oh, no, 5 seconds. 5 seconds is between 4 and 6. This is 4, this is 6. We want to find the acceleration right here. So number 23, acceleration at 5 seconds. So 5 seconds is between 4 to 6. 5 is between 4 to 6. So what is the acceleration over here? Okay, it's very simple. The velocity over here is 2. So 2 minus, okay, so acceleration is Bf minus Vi over delta t. Delta t is 2. 2 minus Bf is 2 minus 0. So acceleration is 1. Okay, so 1 meter per second square. Acceleration is 1 meter per second square. Okay.
All right, so you're gonna do the last problem. Throw a ball up, and this is 50 meter tall, and with 15 meter per second at 90 degree. I wanted to find the velocity at, let me take a look. Velocity at 4.5 second and distance at 3.7. So velocity at 4.5 second and distance at 3.7 second. Okay, so finding velocity at 4.5 second is very easy. So Vf is equal to Vi plus At. All right, so Vf is equal to Vi is 15 minus 10 t. T is 4.5. So Vf is equal to 15 minus 45. So Bf is equal to negative 30 meter per second. So that's easy. The finding, so velocity right here. So this is t is equal to, I don't know, probably 5 over here. So velocity right here is negative 30 meter per second. Okay, now we're going to find the distance at right here. Distance at 3.7 second. Distance. Okay, so we're going to find the time over here, and that will allow us to find the distance. Because from acceleration from here to here is negative. Acceleration from here to here is negative. Acceleration from here to here is also negative. So acceleration is negative both ways. What positive? Velocity is from here to here is positive. Velocity from here to here is negative. So you want to treat. So velocity is negative. Velocity is positive. So that's why we're going to treat them separately. Okay, so d is equal to vit plus half at squared. We want to find the time. We can find the time this way. We can find the time this way. Vf is equal to vi plus at. 0 is equal to 15 minus 10t. So 1.5. Time is 1.5. So we're going to find, okay, so this is what we're going to do. Okay, so 15 vt, 15 over here. What we're going to write over here is 3.7. Let's first calculate this one, and then we're going to calculate this one. We're going to find this one. Vf is equal to vi plus at. Vf is 15 minus 10. T is 3.7. So 15 minus 37. So 2. So 22. So negative 22. Okay, so what we want to do is we want to find this area and this area and add them up. Let's first find this area, half dh. Half d is 1.5 and h is 15. So this is 11.25. So now we're going to find this area, half bh. Half b is 3.7, 1.5. 3.7 minus 1.5 is 2.2. H is negative 22. .2. So let's see how much. 22 times 2.2 times 0.5. 24.2. So we want to take the absolute value, so 24.2. We're going to add them up, 11.25. This is 5, this is 4, this is 5, this is 3, 35.45. So 35.45. Okay, so that's it for the exam number 3, AP Physics 1. I took my time to solve each and every problem. It took me a long time, but I still did it. Hopefully, you want to use it as a resource, not only for the exam 4, but also for the AP Physics 1 test you're going to take on Maths, because this exam is the review for kinematics.